Alrighty, so this problem is part of page number 3, which has part A, part B, and part C. So this problem pertains to part C from page number 3 on the exam 4 in relation to antiderivatives. So in this problem, we have a definite integral of absolute value of 2 plus 2t dt. So how do we approach this? So first, given that this expression right here is an absolute value, what we want to do is we want to set this equal to 0 and solve for t. So we do 2 plus 2t equals to 0. And now we just solve for t. So we have 2t equals -2, like both sides by 2. So t, in this case, we just equal -1. So now that t is -1, we have the interval -2 to 6. So this t equal -1 is going to be part of this interval right here. So we want to do a number line, sign chart. So we want to include the intervals. So we do -2, -1, and then you have 6 right here. So we want to find the signs for each interval in order to apply this to the expression. So in this case, we want to use a value between -2 and -1 in order to apply it to this expression right here in order to find whether or not it is negative or positive. So in this case, we can just use the value of f of -1.5, which plugging it in will just give us a negative value in that case, because plugging, so 2 times -1/2 is just -3, then 2 plus -3 is just -1, so it just result in a negative. And then over here, we just insert f of 0 because 0 is a value between -1 and 6. So in this case, we insert 0 into t, we just get 2, because 2 times 0 is 0, 2 times 0 is 0, and then we just have the 2 remaining over here. So in this case, this would be positive. So now that we have the signs for both intervals, and we have both intervals as well too, we want to rewrite this in terms of the 2 intervals that we have. So in this case, given that we have interval -2 to -1, we can just write integral of -2 to -1 of 2 plus 2t dt plus this interval right here, which is going to be integral of -1 to 6, 2 plus 2t dt. So this whole expression should lead to this, because we have both intervals right here, and we have that they both pertain to the absolute value that we have in this expression. So now that we have the 2 expressions, we want to find the antiderivative of each and then apply the definite integral concept, which refers to the usage of f of b minus f of a in order to find the final answer. So in this case, we want to first find the antiderivative. So the antiderivative of this would just be 2t plus 2t squared over 2. And then the definite integral of -2 to -1, and then plus 2t as well, plus 2t squared with the definite integral of -1 to 6. So we can just simplify these. So in this case, it would just be 2t plus t squared of definite integral of -2 to -1 plus 2t plus t squared. Oh, forgot to put it right here. Oh, definite integral -1 to 6. So given that we have both antiderivatives right here, we want to apply the f of b minus f of a rule. So this represents a, this represents b. So what we want to do is write a big parentheses and just do the math. So we want to plug both of these values into the expressions. So in this case, we'd have 2 times -2. Oh, sorry. We should start with b, not with a. So in this case, we want to start with the bigger value. So in this case, it would just be 2 times negative 1 plus negative 1 squared minus, just put bigger parentheses around this, minus 2 times negative 2 plus, sorry, not t, it's supposed to be negative 2 squared in this case, and then that's the first expression right here. And now we add that over here to this integral. So we want to have 2 times 6 plus 6 squared minus 2 times negative 1 plus negative 1 squared as well too. So we have the big expression right here, so we want to just solve individually and just bring it all together. So we want to start off with this one. So right here in this first expression we have negative 2 plus 1 minus, in this case we want to put big parentheses just to like differentiate between the two, so it would be minus negative 4 plus 4. So we have the first big parentheses done. Then when we want to add this integral expression to that integral expression over here, to the simplified one. So 2 times 6 is 12 plus 36. And we want to write parentheses around that, minus negative 2 plus 1. And just like that, we have the two expressions right here. So we want to continue going down the line. So in this case, we have negative 1. And then we want to transfer this negative into here. So it would just be plus 4 minus 4. And then big parentheses around here. Plus 48 minus 1. It would actually be plus 1 in this case, because negative 2 plus 1 is just negative 1, and then applying the subtraction over here would just be positive 1. So now we have these two. So in this case, we'd have negative 1, and then plus 4. Oh, sorry, that's not what I meant. In this case, we just have negative of negative 1 plus 49, which in this case will just give us 50, because this negative applies to the negative over here, so it just turned into a positive 1 plus 49, that just equals 50 right over here. I can just like rewrite that more nicely. But where did we get this negative from? Because this negative came from this interval right here, because this interval right here was negative. So in this case, I didn't have enough space to write out the negative, but this negative for the first interval of negative 2 to negative 1 was negative, because all the values within this interval lead to a negative rate of change. Whereas in the other one, it was just positive, so we just left it as it was in this case. So applying this negative into the negative 1, so negative times negative is equals to positive. So in this case, negative times negative 1 is just positive 1 plus 49 equals 50. So 50 should be the final answer for this problem. Thank you.